In this lesson, we will look at the behavior of functions, particularly in relation to what we call relative maximum and relative minimum values of a function. If you want to study the behavior of a function, what do you actually do? Well, the best thing to do is to draw a graph of the function. The graph of a function actually tells you stories about the function. Is that right? It's a pictorial representation of the function. Now, let's take, for example, a graph something like this. We got the x-axis and the y-axis, and let's say this is the graph of a function. Now, it tells you a lot of stories about what that function behavior is. For example, now here I'm going to say this is x equal to a. This is x equal to b. Now, the domain of this function is from negative infinity to positive infinity. Now tell me, what is the behavior of this function from negative infinity to negative a? Let me write that here. From negative infinity to negative a, what is the behavior of the function? You can see the function value is decreasing. As x increases from negative infinity to a, the function value is decreasing. So we have a decreasing function on the interval negative infinity to a. And how about from x equal to a to x equal to b? From x equal to a to x equal to b, the function is increasing. I hope you understand the meaning of what it means a function is increasing. It means when x increases, the function value increases. A decreasing function means when the input increases, the output decreases. So, on the interval a to b, the function is increasing. How about on the interval b to infinity? On the interval b to infinity, the function is decreasing. Now, there you have a good description of the behavior of the function. Now, if the function is decreasing from negative infinity to a and increasing from a to b, what can you say about f of a? Look at this. The output at x equal to a is what we call f of a, or that point is called a f of a. What can you say about f of a? F of a is a relative minimum. In fact, in this particular location, that is a minimum value. Is that right? So I'm going to call it a minimum. We call it a relative minimum because there may be other places where the function has a minimum even lower than this. So we can call this a relative minimum or a local minimum. So let's call it a relative minimum or a local minimum. Okay, how about f of b? From a to b, the function is increasing. From b to infinity, the function is decreasing. Therefore, what can you say about f of b? This point will be b f of b. And f of b, therefore, can be called a local maximum or a relative maximum. So I'm going to write that. This is a relative maximum. a relative minimum or at a relative maximum, what can you say about the derivative of the function? Remember, derivative of a function at a point is the slope of the tangent line at that point. So if I draw a tangent line at x equal to a, or a tangent line at x equal to b, you can see that tangent line is horizontal, and the slope of such a horizontal line is 0. What that tells you is that at a relative minimum or at a relative maximum, f prime of x equal to 0. So we can make that statement: f prime of x equal to 0 at f of a and also at f of b. F of a is a relative minimum, f of b is a relative maximum. So wherever you have a relative maximum or a relative minimum, the derivative of the function is 0. Now, such a point where you get a relative maximum or a relative minimum where the derivative is 0 is called the critical point. Critical point. So you can see b, f of b, this point is a critical point. A, f of a, this point is a critical point. And the value of x corresponding to that critical point is called the critical value. The critical value. So the critical value is the value of x where a relative minimum or a relative maximum occurs. So what is a critical value? We said a critical value is the value of the independent variable, value of x, where the derivative equal to 0, where you get a relative minimum or a relative maximum. Now, you can also get the derivative to be 0, or you also can get a critical number where the derivative is undefined. Look at a point like this. It actually represents a relative maximum, but here the derivative is not equal to 0. Why not? Well, because the slope of the tangent line can have two values, because it's a sharp corner. We say here f prime x is undefined. Now, this is also a critical point. So you got to include both when you define critical point. So now what's the definition of a critical point? A critical point is the value of the independent variable, or in most cases we use x as the independent variable. So we can say it is the value of x where f prime x equal to 0 or f prime x is undefined. A critical value is the value of the independent variable where the derivative is either 0 or undefined, and that is the closest definition of critical value that we will be using. Let's now find the critical number of a function like this. F of x equal to 4x over x squared plus 1. Well, what is a critical number or a critical value? A critical number or a critical value is the x value where the function, the derivative of the function is either 0 or undefined. So we start by finding the derivative of this function. All right, let's write down the function. f of x equal to 4x over x squared plus 1. Alright, help me find the derivative of this. F prime of x equal to, this is a quotient, so we need to apply the quotient rule. What's the quotient rule? Denominator times derivative of the numerator minus numerator times derivative of the denominator all over square of the denominator. Alright, let's do that. Denominator x squared plus 1 times the derivative of the numerator. Derivative of 4x with respect to x is 4 minus numerator times the derivative of the denominator. What is the derivative of x squared plus 1 with respect to x? It is 2x. All over square of the denominator, x squared plus 1 raised to the power of 2. Simplify that. That will be, distribute that 4x squared plus 4 minus 8x squared. And that's equal to, well, we have a denominator, don't we? Yes, so that divided by x squared plus 1 whole square. Now that will be equal to, the numerator is 4x squared minus 4x squared is negative 4x squared. 4 minus 4x squared over x squared plus 1 whole squared. And that can be further simplified as 4 common denominator, common factor, 4 times 1 minus x squared divided by x squared plus 1. Okay, how do you find the critical numbers? Critical numbers occur where the derivative equal to 0 or undefined. Now, if you put derivative equal to 0, f prime x equal to 0, remember, a quantity like this becomes 0 when the numerator is 0. So, f prime x equal to 0 occurs when the numerator of the derivative, or 4 times 1 minus x squared equal to 0. Well, 4 times 1 minus x squared, 4 cannot be 0. So I'm going to now write over here. 4 times 1 minus x squared becomes 0 when 1 minus x squared is 0. So I'm going to write 1 minus x squared equal to 0, or x squared equal to 1. And what are the values of x? That will give you x squared equal to 1. X equal to plus or minus 1. So the critical numbers are x equal to 1 or x equal to negative 1. Alright? We also said a critical number can also occur where the derivative is undefined. Now, when will a quantity like this, which is the derivative, when will a quantity like this become undefined? It becomes undefined when the denominator equal to 0. Now, what is the denominator here? The denominator here is x squared plus 1. Now tell me, can x squared plus 1 be ever equal to 0? Can x squared plus 1 be equal to 0? Well, I don't know whether you said anything, but if this is equal to 0, then x squared will be negative 1. Is that right? That cannot happen. That means x squared plus 1 cannot be equal to 0. Or there are no x values that will make the derivative undefined. What that tells you is that these are the only critical numbers of this given function. All right. If I ask you what are the critical points, then for each x value, you got to go and evaluate the y value. And that will give you each critical point. But these are the critical values or the critical numbers. All right. Can you now draw the graph of this function f of x equal to 4x divided by x squared plus 1, where we found the critical numbers are x equal to plus or minus 1. Try drawing the graph of this and see whether you really can identify the critical numbers. All right? Take a minute and draw the graph, and I will do that by the time on the board. Well, how does the graph of 4x over x squared plus 1 really look like? Well, it looks almost like this, I think. It sort of decreases, increases, is that right? Now, take a look at it and see whether I got it fairly all right. Well, this is x equal to -1. That is a critical number. This is x equal to 1, and that is another critical number. This is a critical point, and that is the other critical point. Now tell me, what is the value of this? This is x equal to -1. What's the value of y when x equal to -1? When x equal to -1, f of -1 equal to, when x equal to -1, it will be -4 over -1 squared plus 1 will be 2, and that will be -2. So that will be -1, -2. That is one critical point. How about this? That will be x equal to 1. What is the value of y? Well, the value of y is 2. So that's a critical point. That's a critical point. And if you look at the behavior of this function now, from -∞ to -1, the function is decreasing. From -1 to 1, it is increasing. And from 1 to infinity, it is decreasing. You see how the graph of a function tells you the whole story of the function. And so whenever we talk about a function, we need to look at its graph in order to understand it well. Now, I want to apply a small correction to the definition of a critical number that I gave you in the beginning of the lesson. We said the critical number is the value of x where the derivative is 0 or undefined. But there is a small danger in that statement, because for a number of x values, when the derivative is undefined, that x value may not be in the domain of the function. For example, if I have a f prime of x equal to, say, x over x minus 1. This is the derivative of some function. Well, the critical numbers can occur when the derivative equal to 0. In other words, x equal to 0 is a critical number. It can also occur when the derivative, where the derivative is undefined. Now, this derivative becomes undefined when this denominator becomes 0, or at x equal to 1. But x equal to 1 is not in the domain of the original function. If this number is not in the domain of the original function, then this cannot be a critical number. So you've got to add that to the definition. So what is the definition of a critical number? A critical number is the x value where the derivative equal to 0 or undefined, provided that x value is in the domain of that function. Alright, let's now find the critical numbers of this function. F of x equal to x times square root of 2 minus x. Now here we have a product. So first we find the derivative of the function, because critical numbers occurs where the derivative is either 0 or undefined. So let's find the derivative. Help me find the derivative. F prime x equal to a product. First function times the derivative of the second function, plus second function times the derivative of the first. Alright, and you should now know very well the derivative of a square root quantity is 1 over 2 square root of that quantity times the derivative of that quantity. Alright, tell me briefly, what is the derivative of square root 2 minus x? The quantity here is 2 minus x. The derivative of this will be 1 over 2 square root 2 minus x times the derivative of 2 minus x. What is the derivative of 2 minus x? The derivative of 2 is 0. The derivative of minus x is minus 1. So the derivative of 2 minus x is negative 1. Alright, let's write that down. It will be the first function, that is x times the derivative of square root 2 minus x. The derivative of a square root quantity is 1 over 2 square root 2 minus x times the derivative of the quantity 2 minus x, which is negative 1. I hope that is clear. The derivative of 2 minus x is negative 1. Plus the second function square root 2 minus x times the derivative of the first. The derivative of x with respect to x is 1. Well, let's rewrite that. That will make the numerator here negative x, is that right? That will be negative x over 2 square root 2 minus x plus square root 2 minus x. Now, I'm sure your algebra is good enough to simplify this by taking the common denominator. Now, remember I showed you some time ago that if you have a over b minus c, this will be b becomes common denominator, and b then will multiply with c on the numerator. What will be the numerator? The numerator will be a minus bc. In the same way, here, when, what's our common denominator? Common denominator is 2 square root 2 minus x. And the numerator, this negative x will remain, plus here, this will multiply with this. Is that right? Now, what is square root 2 minus x times square root 2 minus x? That will be 2 minus x. So that will be 2 times 2 minus x. I hope that simplification is clear. It's very elementary algebra. And what is that equal to? That will be negative x plus 4 minus x. Is that right? That will be negative x plus 4 minus 2x. Distribute that 2. Plus 4 minus 2x all over 2 square root 2 minus x. Alright, let's simplify that again. That gives me negative 3x plus 4, or 4 minus 3x, all over 2 square root 2 minus x. And that is the derivative of the function f of x equal to x square root 2 minus x. So what are the critical numbers of this function? What we need to do is set the derivative equal to 0 first. Now, when the derivative equal to 0, remember always the derivative becomes 0 when the numerator equal to 0. So, if we say f prime x equal to 0, we will say 4 minus 3x equal to 0. Set the numerator equal to 0. That's when the derivative becomes 0. 4 minus 3x equal to 0 will give you x equal to 4 over 3. And this is one critical number. X equal to 4 over 3 is one critical number. Is there another critical number? Well, another critical number occurs where the derivative is undefined. Tell me, is there any x value where the derivative is undefined? Well, the derivative becomes undefined when the denominator becomes 0. Now, is there any value of x that will make the denominator 0? Yes, when 2 minus x becomes 0, the whole of the denominator will be 0. So, if you set 2 minus x equal to 0, that will give you x equal to 2. X equal to 2 could be a critical number. But is it actually a critical number? Go and look at the function again. Is that a critical number? X equal to 2. Is that in the domain of the function? Well, it is in the domain because square root of 2 minus x. The condition is that 2 minus x has to be greater than or equal to 0. Is that right? And that happens when will this happen? This will happen when 2 is greater than or equal to x, or x is less than or equal to 2. That's right. So, there are no x values in the domain of this function that are greater than 2. If you draw the graph of this function, there will be no output beyond x equal to 2. Now, I want you to draw the graph of this function and take a look at it. So, now tell me, is x equal to 2 a critical number or not? Well, it satisfies the condition, is that right? At x equal to 2, the derivative is undefined, and x equal to 2 is in the domain of the function. But anything greater than 2 is not in the domain of the function. Therefore, x equal to 2 is another critical number. So the critical numbers are x equal to 4/3 and x equal to 2. So we found the critical numbers are x equal to 4/3 and x equal to 2. Can you verify that by drawing the graph of this function? Alright, take a second and draw the graph of the function by the time I do it on the board. Well, I would expect to see a maximum or minimum at x equal to 4/3. Is that right? Well, if this is x equal to 1, and that's x equal to 2, I would see a maximum somewhere here. And how does the graph go? I hope you got the graph by now. I think it will go somewhere like this, and let me come again. It'll come like this. Now, At x equal to 2, you would notice when you draw the graph that the graph will stop there. This is the last output you get. What is f of 2 equal to? Can you look at the function and tell me what is f of 2 equal to? If you put x equal to 2, this will be 0. 0 times anything is 0. Therefore, f of 2 equal to 0. So this point, which is 2, 0, is a relative minimum. And this is x equal to 4/3. And whatever value you get there, that will be a relative maximum. The function increases from negative infinity to 4/3 and decreases from 4/3 to 0. All right, I hope you got the graph on your calculator. Let's now find the critical numbers of f of x equal to sine x plus tan x. Well, it's a peculiar function, is that right? Would you like to draw the graph of this and see how that looks? Or maybe you can do that after we find the critical numbers. So f of x equal to sine x plus tan x. We start by finding the derivatives. So we have f prime of x equal to sine x plus tan x. The derivative of sine x with respect to x is cos x. Plus, what is the derivative of tan x with respect to x? Is secant squared x. Okay, to find the critical numbers, we set the derivative equal to 0. Okay, can you help me solve that equation? Cos x plus secant squared x equal to 0. One of the things that you should look for when you want to solve a trigonometric equation is to bring all the terms to the same type of ratio. In other words, if you have cos x and secant x, it is not easy to solve it. But you know that secant x can be written in terms of cos x, can't you? Secant x is 1 over cos x. So if you write secant squared x as 1 over cos squared x, then you have only one type of ratio and you can solve that easily. So let's do that. That means cos x plus secant squared x is 1 over cos squared x equal to 0. And solve it, we will now take cos squared x as the common denominator. It will now become cos squared x times cos x is cos cube x plus 1, and set that equal to 0. Now you have a numerator and denominator. A quantity like this becomes 0 when the numerator equal to 0. So let's take the numerator and set it equal to 0. Cos cube x plus 1 equal to 0 will give you cos cube x equal to negative 1. All right, tell me, cos cube x equal to negative 1. Cos x times cos x times cos x equal to negative 1. What is the value of cos x? If cos cube x equal to negative 1, what is the value of cos x? Well, it is negative 1. All right, when does cos x become 0? By the way, we are only interested in that interval 0 to 2 pi because the graph will extend from negative infinity to positive infinity. We are only interested in, say, 0 to 2 pi. Tell me, on that interval, cos x equal to negative 1 will give you x equal to what? Well, I've been telling you from the beginning that these ratios, it must be very, very thorough. You must be very thorough with it. You must be able to pick it quickly. Cos of pi, what is cos of pi? Cos of pi is -1. Cos of 0 is 1. Cos of pi is -1. So cos x equal to -1 gives you x equal to pi. So one critical value is x equal to pi. At x equal to pi, you will have either a maximum or a minimum. Well, we got x equal to pi by setting the numerator equal to 0. But the critical value can also occur where the derivative is undefined. Alright? And that happens when cos x equal to 0, where the denominator is 0. Well, cos x equal to 0 will give you what x values? What are the values of x that makes cos x equal to 0? Cos of pi by 2 equal to 0. So pi by 2 is one value. On 0 to 2 pi, cos of pi by 2 equal to 0. Cos of 3 pi by 2 equal to 0. So these are both values of x that will make cos x equal to 0 on that interval. Therefore, we have now x equal to pi, one critical number, x equal to pi by 2, and 3 pi by 2 are two possible critical numbers. But are these in the domain of the function? Now, if you remember, if you put x equal to pi by 2 there, what is tan of pi by 2? Well, you must know that tan of pi by 2 is undefined. That means pi by 2 is not in the domain of the function. How about 3 pi by 2? If you put x equal to pi by 2 here, tan of 3 pi by 2 is undefined. Well, I hope you understand how the graph of tangent looks like. Just draw it on your calculator and see how it looks like. At pi by 2 you have a vertical asymptote. At 3 pi by 2 you have a vertical asymptote. So, if you look at the graph of tangent, this is pi by 2. So at pi by 2, and it will repeat the same way. If you let me take that out, I can show that graph. Now, this is pi by 2, this is 3 pi by 2. You will get the tangent graph going like this. So pi by 2 is not in the domain, 3 pi by 2 is not in the domain. Therefore, these are not critical numbers, because those are not in the domain of the function. Alright, can you now draw the graph of this and see how that looks? Now, before we move on with the lesson, I want you to stop a while and find the critical numbers of this function, f of x equal to sine x. Well, you know how the graph of sine x look like. And do that on the interval 0 to 2 pi. Alright. Another one I want you to try is f of x equal to x times x minus 5. Try both these and obtain the critical numbers. Always check by drawing the graph on the calculator. We will now look at the concept of absolute maximum and absolute minimum. Now, we will always look for the maximum and minimum in a certain given interval. Now, in a given interval, a function may have more than one maximum or more than one minimum. Now, therefore, a particular minimum or a particular maximum we call relative minimum or relative maximum. All right. Let me draw a hypothetical graph, not the graph of a real function, but I just made it up. Now look at this. That is a hypothetical graph. If you look at this, there's a local minimum here, a relative minimum here, a relative maximum here, a relative minimum here, and so on. There are many. That's x equal to a, and that is x equal to b, and we are studying the behavior on the interval from x equal to a to x equal to b. So in the closed interval from x equal to a to b, there are 4 relative maximums. That is, well, that is the maximums. Here is that right, at x equal to a. 1, 2, 3, 4. There are 4 relative maximum and 4 relative minimum. There's 1, 2, 3, 4. That's the relative minimum. So, relative maximum 1, maximum 2, relative maximum 3, and relative maximum 4. Similarly, minimum 1, 2, 3, and 4. That may be out of the screen, but you can imagine there is one there. Now, the absolute maximum in the interval AB, what is the absolute maximum? If you look at this graph, the absolute maximum is the maximum you can obtain on that interval. And which is that? Actually, that is the relative maximum 3. And what is what is the absolute minimum? It looks like it is the relative minimum 2. Now, therefore, what do we do if you want to find the absolute maximum and absolute minimum of a function in a given interval? For example, I'm going to draw an interval here on the computer. Let me see if I can draw it. Suppose that is your A and that is your B. Now, I have drawn an interval here. That is A and that is B. Let me label that. That's your A. Oh, well, that's your B. Now, on that interval, if you look at here, f of A is a relative maximum. There is a relative minimum here. There is a relative maximum there. And f of B is a relative minimum. And so, if you want to find the relative maximum or minimum of a function, what do? The first thing you do is find the critical numbers of the function on that interval. And if you notice, this is a critical number, that's a critical number. Now, once you find the critical numbers, find the values of the function at the critical numbers and also at the end points of the interval, because a maximum or a minimum can occur at the end points also. So, once you have the critical numbers, find the values of the function at each of the critical numbers and also at the end points of the interval. Then, the maximum value of the maximum is the absolute maximum, and the lowest of the minimum will be the absolute minimum. And those are the steps that we will be using to find the absolute maximum and the absolute minimum of a function in a given interval. Let's summarize this. To find the absolute maximum and the absolute minimum of a function on the interval AB, what do? Obtain the critical numbers by setting f prime x equal to 0, and then find the values of the function f of x at the critical numbers and also at the endpoints. Endpoints are f of a and f of b. That means you have several values of the function. The function values evaluated at the critical numbers and also evaluated at the endpoints of the interval, f of a and f of b. Now, the highest maximum is then the absolute maximum, and the lowest minimum is the absolute minimum. All right? Let's practice it with an example. Find the absolute extrema. Well, extrema simply means maximum or minimum of f of x equal to 3x to the power of 4 minus 4x cubed on the interval. If you cannot read it on the screen, it is -1, 2. On the interval, -1, 2. How do we start? We first find the critical numbers by setting the derivative to 0. All right, let's first find the derivative. Our function is f of x equal to 3x cubed, x to the power of 4 minus 4x cubed. The derivative will be, what's the derivative of 3x to the power of 4? It will be 12x cubed minus 12x squared. That is the derivative. Now, set the derivative equal to 0. That will be 12x cubed minus 12x squared equal to 0. How do you solve that? Factor out the common factor. What's the common factor here? 12x squared is common. So 12x squared times x minus 1 equal to 0. And that's now simple. What are the values of x that will make this expression 0? First, x equal to 0. X equal to 0 is 1. And when x minus 1 equal to 0, x equal to 1. And these are the critical numbers. X equal to 0 and x equal to 1 are the critical number. Now, there are no values of x that makes the derivative undefined here because we don't have a denominator. And therefore, what do we do now? We know the critical numbers. We know the interval. So, evaluate or find the values of the function at the critical numbers and also at the endpoints at x equal to -1 and x equal to 2. So find the values of the function at the critical numbers and at the endpoints. Let's do that. F of 0 is, what's the value of the function when x equal to 0? When x equal to 0, the function value is 0. So f of 0 is 0. F of 1, replace your x by 1 in the function. It will be 3 times 1 to the power of 4 minus 4 times 1 cubed, and that is -1. Now, we have evaluated the function at the critical numbers. Now, evaluate the function also at x equal to -1 and x equal to 2. F of -1, replace your x by -1. It'll be 3 times -1 to the power of 4 minus 4 times -1 to the power of 3. It's very important that you do this without making a mistake. So once you make a mistake on this, the error will be compounded. And this is equal to 7. And one more, we need to find f of 2. So f of 2 is 3 times 2 to the power of 4 minus 4 times 2 cubed, and that's equal to, you should be able to do it mentally. You see, 2 to the power of 4 is 16. 16 times 3 is 48. 2 cubed is 2 cubed is 8. 8 times 4 is 32. And 48 minus 32 is 16. Now, you got the values of the function at the critical numbers and also at the endpoints. The absolute maximum is the maximum value that you find here. So what is your absolute maximum? Your absolute maximum is f of 2, that is 16. And your absolute minimum is the lowest of all the 4 values is -1. Now, look at the graph of this function. The absolute maximum occurs when x equal to 2, and that occurs actually at the end point. Now, x equal to 2, y equal to 16. And that is where the absolute maximum occurs. This is x equal to -1, and that is x equal to 2. So this is the absolute maximum, and this is the absolute minimum over here. That's right. So absolute maximum is 16 over here, and the absolute minimum is -1 over here. All right. Let's try another one. Find the absolute extrema of f of x equal to sine x plus cos x on the interval 0 to pi by 3. And you can see the bracket I used showing that the interval is closed. All right. How do we go about doing it? First of all, we start by finding the derivative. F of x equal to cos x minus sine x. What is the derivative? The derivative is, well, f of x is sine x plus cos x. The derivative will be, the derivative of sine x is cos x. The derivative of cos x is minus sine x. So f prime x is cos x minus sine x. Set that equal to 0. I'll give you cos x minus sine x equal to 0. All right. Can you stop the video for a second and solve that equation? So cos x minus sine x equal to 0. You can actually think a little more rationally on it. If cos x minus sine x equal to 0, what is the value of x? If you know your trigonometric ratios, if cos x minus sine x equal to 0, it means cos x equal to sine x. For what value of x is cos x and sine x are the same? Well, you should know that sine of 0 is 0, sine pi by 6 is 1/2, sine pi by 4 is root 2 over 2, sine pi by 3 is root 3 over 2, sine pi by 2 is 1. And you start cosine. Cos of 0 is 1, cos of pi by 6 is root 3 over 2, cos of pi by 4 is root 2 over 2, cos of pi by 3 is 1/2, cos of pi by 2 is 0. Did we have a common number somewhere? Yes. Sine of pi by 4 and cos of pi by 4 are both equal to root 2 over 2. That's right. Now, in order to solve this, let's divide both sides by cos x. What does that give you? If you divide each term by cos x by cos x is 1. Sin x divided by cos x is tan x. And of course the right side is 0. 1 minus tan x equal to 0. And that gives you tan x equal to 1. If tan x equal to 1, what is x? Tan of what equal to 1? Tan of pi by 4 equal to 1. So you get x equal to arctan 1, and that gives you x equal to pi by 4. You can see, you can also solve the way I argued out earlier, where sin x equal to cos x. All right, now we've got the critical number x equal to pi by 4 is a critical number in the first quadrant. Well, we are looking for 0 to pi by 3. We are looking for on the interval 0 to pi by 3. Therefore, you can also have x equal to 5 pi by 4. That is the third quadrant. That is outside our interval. So, on the interval 0 to pi by 3, the critical number is only pi by 4. And therefore, let's evaluate the function. Find the value of this function at the critical number x equal to pi by 4. That will be sine of pi by 4 plus cos of pi by 4. Well, if you followed Just some time ago I said sine of pi by 4 is root 2 over 2. Cos of pi by 4 also is root 2 by 2. So is root 2 over 2 plus root 2 over 2 is root 2. The function value at x equal to pi by 4 is root 2. We found the value of the function at the critical number. We need to find the values also at the end points. F of 0. F of 0 is sine of 0 plus cos of 0. Sine of 0 is 0, cos of 0 is 1. So sine of 0 plus cos of 0 is 1. How about pi by 3? Find the function value at x equal to pi by 3. Sine pi by 3 plus cos pi by 3. I have been giving you all these values. Now remember, the more times you write down these values, the better you remember. So write them down as many times as possible. Sine of pi by 3 is root 3 over 2. And cos of pi by 3 is 1/2. So it'll be root 3 over 2 plus 1/2. And that's approximately 1.37. So we now have the values of the function at the critical number. F of pi by 4 is root 2, and f of 0 is 1, and f of pi by 3 is 1.37. Tell me, what is the absolute maximum of this function on this interval? Which of these three has the maximum value? What is square root of 2? Well, I know you will go to the calculator, but you must have a fair understanding. Square root 2 is 1.414. So, square root 2 is greater than 1.37. And you can see the graph of the function. Now, at pi by 4, this is x equal to pi by 4. Absolute maximum is square root of 2. And absolute minimum is 1. That's right. Okay. Now, try one on your own. Find the absolute maximum and the absolute minimum of f of x equal to 3x to the power 2/3, 3x to the power of 2/3 minus 2x on the interval -1 to 2. All right, try that on your own, and I have given you the answer. The absolute maximum is 5, absolute minimum is 0. Now, don't leave your desk without finishing it. Try that and make sure that you understand it. All right? All right, if you have done this, then try another one. Find the absolute maximum and the absolute minimum of f of x equal to tan x on negative pi by 4 to pi by 4. And the answer is absolute maximum is 1, absolute minimum is -1. You must do this and also try the graph and make sure that you understand the behavior of the function on the given interval. Times